Okay, so in our last video, we were talking about discrete random variables, and we were talking about how we can write them out in terms of like a support and our probability mass function. So let's go back to our unique dice, and we'll give it a shot. So what we do is write our little x as our support and the probability of our discrete random variable equaling a specific member of the support. So this is our probability mass function. Okay, and if you remember from our dice, it had three sides that had 0, a side that had a 1, a side that had a 2, and a side that had a 3. So our options here were 0, 1, 2, and 3. Now the associated probabilities for each of these, there was a 50%, oops, not a 1/5, that is, give me a second, let me find there it is. Much better. There we go. A 50% chance of being 0, 1/6 of 1, 1/6 of 2, and 1/6 of 3. Which means that, okay, every time we roll the dice, 50% chance of getting a 0, 1 out of 6 for 1, 1 out of 6 for 2, 1 out of 6 for 3. All right, so that's known as our probability mass function. Now we can also include what's known as our cumulative distribution function. So this is x, our discrete random variable, capital X, is going to be less than or equal to little x. And this is our cumulative distribution function. Or just shorthand, this will be our CDF. So since we're dealing with a discrete random variable, we must know that we can be less than or equal to any specific value. So the probability of being less than or equal to 0 is just 1/2. We can't have like a negative value on this dice, but we could get a 0. Okay, so less than or equal to 1 is going to be, well, if we convert 1/2, that's also equal to 3/6. So this would be 4/6, which is, we can simplify that down to 2/3 if you want. And then this guy is going to be 5/6. And then this last one is going to be 6/6, which is equal to 1. So on our CDF, the last value in your CDF will always equal 1. You'll know you've done it right if the last one is 1. So some other concepts here is that our probability mass function, every single outcome must have an associated probability. It can be anywhere between 0 and 1, because any probability can be between 0 and 1 inclusive. Can't be more than 1, can't be less than 1 in our PMF. Our support should be every value that actually is possible. So we've got 0 through 3. Now we could technically add in something like 4, but on our specific dice here, the probability of rolling a 4 is 0. So we really wouldn't change anything there. And so we leave it off. So this is our discrete random variable. This is our kind of table of our support. Let me write that down again. This is our support. This is our probability mass function. This is our cumulative distribution function.